The next example, example 4, it actually, to me, I think it kind of starts off looking a little bit intimidating. We have natural log of x all raised to the 4th power over x dx. But you'll see that if we use, and when we look at this, we think, okay, does this fit the du over u pattern? If I take the derivative of x, I certainly don't get natural log of x to the 4th power, right? So it doesn't follow that pattern. So I kind of go back to the, let's try the innermost part of this function that we can see, and it's this thing raised to the 4th power. So you notice that if I let u equal ln of x, I get my du is 1 over x dx. So that takes care of the 1 over x dx for me. And then what I get is just a nice u to the 4th. And so in this case, you notice that we aren't getting a du over u, but we are using the derivative of natural log of x. So we're using that 5.1 information to find our du. So we really couldn't, even though we get a u to the 4th, we really couldn't have set up this u and du before we got to chapter 5. Right? So of course when we integrate it, it's a real easy 1 over 5 or 1/5 times u to the 5th plus c, and we get our 1/5 ln of x to the 5th plus c. So the next one, tangent of x. So tangent of x, if we try to do that without any u substitution, we might be tempted to kind of think of, okay, well, what's pst, right? So it's, if I take the derivative of tangent, I get secant squared. But if I want the antiderivative of tangent, there is no just direct antiderivative of tangent, right? Using like a rule that we've memorized. So we have to be careful about that. That's an easy kind of trap to fall into. But you'll see that if we rewrite it as sine over cosine, then we can use some u substitution here. So we can let the derivative, the denominator equal u. So u equals cosine of x, and then du, the differential of u, is negative sine of x dx. So we really only want to replace a sine of x dx. So negative du equals sine of x dx. Now we can replace sine of x dx with a negative du. And so we get the negative sign there, then 1 over u du. And so from there we have an easy integration. It's ln of absolute value of u. We substitute the cosine of x back in there and we get negative ln of cosine of x, absolute value of the cosine of x plus c. The next example is actually a little bit easier for us because it's already written in such a way that we can just do the u substitution. So it's a slightly more complicated denominator, but we don't have to figure out how to rewrite it as we did with the tangent. It's already sine of x over 1 plus cosine of x. So again, if we let the denominator equal u, 1 plus cosine of x, we take the derivative, it's sine of x dx. That's the negative sine of x dx. We're trying to replace sine x dx. So we're going to replace sine x dx with a negative u. Then we integrate it the same way. Now our final result is the negative of the natural log of 1 plus cosine of x inside the absolute value. Next problem we have another kind of intimidating start to the problem. We have 1 over x times the natural log of x squared. Alright, so we need to figure out a way to rewrite that. So here's how I would look at that. I'm going to let u equal just natural log of x squared. Then when I take my du, it's 1 over u times u prime. So I get 1 over x squared times 2x dx, and that will reduce, these x's will cancel out, to 2 over x dx. Now I have the x dx here, and I want to replace the x and the dx there. So here's my u. Here's my x over dx, but I don't really want that too, so if I solve this for 1 over x dx, it's going to be 1/2 du. So 1/2 du equals 1 over x dx. The 1 over x dx gets replaced with a 1/2 du, and this 1 over ln of x squared is 1 over u. So from there, it's an easy natural log of absolute value of u. I have the 1/2 there. I finish by substituting that ln of x squared in there. That's a strange looking answer. Right, so I have 1/2 times the natural log of the absolute value of the natural log of x squared. I really probably don't need, well, I might, depending on what the value of x is. I still might need the absolute value, so I'm going to leave them there. And don't forget your plus c.